Hello everyone, today we will move to the next topics. A very spaces is very important for our class and for probability and applications. Today's topic is we talk about conditioning and bias rule. In this, the two main topic is conditional probability and independence. Here I have an example to show us about the conditional probability. Here's the idea of conditioning. Assume that we have the universe or omega is our universe. Is two sets of A and B. It has some intersects. And in our universe we have 12 equally likely outcomes. This dog is 12. So the probability for each dog is 1/12. Here we have property of A is 5/12. Here we have 1, 2, 3, 4, 5 bonds in set A. In B we have 1, 2, 3, 4, 5, 6. So property of B is 6/12. And here we have some events that not depend on A or B is 3. So property is 3/12. The intersection between A and B is only 2/12. Here is the B intersects with A complement. It not depend on the intersection between A and B, so it is 4 and 3. It is the property of event in the set that we have learned on previous lessons. So here we have some new information to revise our probability model. The first one, if we said that B occur, it means that B occurs, so we will remove 6 events. B occur, only remain as it. So what is property of A in this case, or more precise, property of A given B? Here property of A just only 2 events. B is 1, 2, 3, 4, 5, 6. So property of A given B is 2 versus. It's totally different with these probabilities because in this case we know the B occurred. So this is 2 versus 1/3. So how about property of B given B? Actually, it's a property of B given B. In this case, it's equal 1 because if we know B occurs, so probability that B occurs, we assume that we met B, so probability B must 1. So it's totally different with this value. In this case, we don't know any prior knowledge, but now we know prior knowledge is B occur. So in this sample space, totally different. And here is one example shows us the conditioning. Here is B occur B occur is the condition. The condition. This is condition that. So when this condition happen, so property of A given this condition is different, and also property of this condition because it happened, so property is must 1. If this makes sense, so next we will define a conditional property. A conditional property of A given B, property of A given that B occurs. It defined by this formula. A property of A and B. Here is this reason. Divide property of B. It's defined only when property of B must greater than 0, since this is the upper of fraction. Here has a sample for 2 rows of a 4-sided die. We have 4 sides. You can search the internet how this die it look like, and here we have 2 rows. The first one is X, second is Y, and we have this each time because it is 4-sided, so it's the value is 1, 2, 3, 4, 1, 2, 3, 4 for each time. So let B is the event that the minimum of X and Y equal to. Let M is the event that's the maximum of X and Y. Here is the condition it occurs. It means that minimum of X and Y is 2. So it must here the sample space for event B. The first we resolve with the property. We consider what is sample space. Sample space, as previous slide, is this. We have 5 cells here, M is matched between S and B. So what is property of M equal 1 given B? Because we know that minimum is 2, so this must 0, because cannot minimum is 2, cannot maximum is 1. So how to formulate? Here we calculate equal property of M equal 1 intersect with B and divide property of B equal maximum is 1, so this is only this cell have maximum is 1. So the intercept between of this equals 0, so this property is 0. So how about property of M equal 3 given B? Here same property of M equal 3 intersect with B and divide property of B. Maximum A3 is this cell and this cell, 2 purple cell. The maximum is 3, 5 cells here, is the only had two persisting. Divide probability of B by 5 persisting. Why 16? Because we have the 4 sides. Each side totally self. Our sample space here is the 16. So it 2 thus. In another case, we can count is the 2 cell is the purple, so 2 probability of B is the 5 to 5. Is this make sense for you? Yeah. We can calculate the probability is depend on the event B occur. So here's some probabilities. Here is some properties. First, the conditional probability says properties of ordinary probability. It means that some rule we learned previous slide. First one is much greater than 0, and also we assume that probability of B much greater than 0. And probability of omega is the universe or all possible outcome. Given of B is the probability of omega intersects with B divide probability of B since omega includes B, so probability of omega intersect with B is same with probability of B divide probability of B, and this equal 1. Right? Same here. We saw example previous slides. Now we can prove it. Same formula. Probability of B intersects with B divide probability of B. B intersect with B, it is same probability of B divide probability of B, and this equal 1. Right? So here we have A not destroyed with C, or A intersect with C is an empty set. There's property of A union with C, A union with C given B is this given B, the property is this one equal property A given B plus C given B. How to prove it? Let's see this is the property of A S B C intersect as a formula B divide probability of B we can use the associated rule. It's the A intersects with B union C intersects with B, and probability of B So if string A and C is disjoint, it means that A intersect B and C intersect with B here to C part is totally disjoint, so we can that is equal property of A intersects with B divide property of B plus property of C intersects with B divide property of B. So this same formula here, property of A given B, it is a define of conditional property of C given B. Is this right? Did you understand it? Is C is some properties of conditional probabilities, some properties of conditional probabilities. I'm sorry. We can easily to prove it by the Venn diagram. Here another conditional probabilities. We have models based on the conditional probabilities. Property of A given B is A intersect B, B. Property of B given A is property A intersect B given A. It different with the downside of the fraction. So here even A example, even by is the event that airplanes are flying above. Here is for some radar applications in the airport. We have even A, airplane is flying above, and even B, something resistors on the radar screen. Radar is a device here. It has a signal on the spy and to track everything on the flight. And here we track airplane, and when airplane is free, they have something register on the radar screen. So here's the A, and A complement is A is the property of airplane is fly above, and complement it means that now fly above. A complement. So here property of B given A, it means that very accurate, 99%, means A and B, and here is A but without B is in noise. It means that the airplane is free, but the screen of radar display nothing. And here is the A complement and B. It means that no airplane, but something register on the screen of radar. It is a phone alarm. Phone alarm. It means that nothing happened, but the sensor saw that something happened. And here is nothing, and nothing happened, nothing displays is 90%. So here we calculate some interesting event. First, A and B. It means that airplane is flying and something register on radar screen, and here is a property of A given B multiply with property of sorry, here is property of B given A multiply property of A. So here is this formula. B given A is a 99 multiply of property of A is 0.05. And how about property of B? B is something registered on radar screen and something not registered. We have property of B, so consider what is the leaf on the tree. Happy. Here we have B here and B here. It means that B equal property of A intersects with B plus property of A complement intersects with B. This comes from define of the set property in previous lessons, and here is here we have this 0.99 multiply 0.05 plus here the same in this complement, and this is the 0.95 multiply 0.1. So this is property of B. How about property of A given B? A given B here is a property of A intersects with B divide property of B. Here this formula, we have property of A and B, property of B, so we can easily calculate. And this here is the multiplication of rule. The multiplication, here we have the 3 is the root, and property A complement this example, B again A and B, and here for property of C complement. Right, two event A complements B given A, B complement given A. He C given A and B. We solve it by the 3. So property of A given B is property A and B divide property B. B is the formula. A and B equal property of B multiply AB and A BA. So how about property of A complement and B and C? Easily we can divide in this equal property of A complement and B multiply property of C complement given A complement and B. Just change it. So this equal probability of A complement multiplied by probability of B given A complement multiplied probability of C complement given A complement intersect with B. So this is the multiplication rule. For 3 events, we can expand it into n event. For example, probability of A1 and A2 and AN is equal probability of A1 first multiply probability of A2 given A1 multiply probability of A3 given A2 intersect with A1 and etc. probability of A n slash 1 with A1 to A n minus 1. This multiply rule very important for the graphical probability model that we learn in the application. Here I will solve is the total probability theorem. It means that here is the sum of probability of B. Here sample we have the universe, we divide it into 3 disjoint event A1, A2, A3, and we have some B event. So B can divide in 3 parts too. You see A1 intersect with B, A2 intersect with B, A3 intersect with B. One is exercise, I show this. So here we partition of sample space into A1, A2, A3. We have the every property of AI. So how we can calculate property of BI for every A? Here is sample B equal A1 intersects with B and union with A2 intersects with B and union with A3 intersects with B. Since A1, A2, A3 is disjoint, so we can is the probability of A1 and B plus probability of A2 and B plus probability of A3 and B. From conditional, we can write the probability of A1 multiply probability of B given A1 and same for A2, A3. So this is the total probability can write in this formula. Here is some interesting. Is the A is the downside of conditional and multiply on this. For the continuous space is we will integrate of B, A, B B A I D. So it's the next lesson. Forget it. So this is total property. It means that we can calculate property of B by some success of its event intersects with another property, the prior knowledge, the conditional knowledge. You can divide A1, A2 with 3 and AC B here. We sum of 3K here. EC A1 intersects with B complement with distance consider here. Is this make sense for you? Okay, we move to very important theories in probability. It's a Bayes rule. These rules we consider again the total probability, and Barcelona is same space A1, A2, A3, and device. And here we call it the initial belief or prior belief. We have believed something about, and we revise belief and given per occurs